Good morning, students. Today we will see the architecture of Unix operating system. Okay, as here you can see the diagram for Unix architecture. Let's see it in detail. Here in diagram you can see the three levels, that is user level, kernel level, and hardware level. Okay, the system calls and library interface represent the border between user programs and the kernel. The system calls look like ordinary function calls in C program. Assembly language programs may invoke system calls directly without a system call library. A set of system calls into those that interact with the file subsystem, and some system calls interact with the process control subsystem. So the file subsystem manages files, allocating file space, administrating free spaces, controlling access to files, and retrieving data for user. The processes interact with the subsystems via a specific set of system calls, such as open, close, read, write, etc. The file subsystem accesses file data using buffering mechanism that regulates data flow between kernel and secondary storage. The buffering mechanism interacts with block input-output device drivers to initiate data transfer to and from the kernel. The device drivers are the kernel modules that control the operator of peripheral devices. The file subsystems also interact directly with raw input-output devices drivers without intervention of the buffering mechanism. Finally, the hardware control is responsible for handling the interrupt and for communicating with the machine. The devices such as disk or terminals may interrupt the CPU while the process is executing. If so, the kernel may resume execution of the interrupted process after serving the interrupt. Interrupts are not serviced by special processes, but by special functions in kernel, called in the context of the currently running processes. Thank you.